How's it going, everybody? This video is titled Nth Roots and Exponents. The learning targets for the video. There are sort of three things I want you to come away from this video with. The third one I'm actually going to let you work out in the exercises for this. So it's going to be kind of on you to sort of play around with it, play around with the ideas and make it make sense. But the first two are pretty simple. The first one is just straight up arithmetic. And I believe this is review, but if it's not, that's okay too. We're going to talk about nth roots of numbers, okay? And we'll also talk, number two, we'll talk a little bit about what it means to be inverse to when two operations are inverse to one another. And we'll see that roots, like the nth root of a number, is the inverse to raising to a power, okay? And then three, we're going to look a little bit more at the connection between roots and exponents, but as I mentioned, that's going to be kind of for you to work out. So, okay, first thing, just a quick vocab word here. Inverse in math means really like the same thing inverse you think of in an ordinary English, right? So when two things are inverse, it's like they're kind of opposite somehow. So in math, we'll say that two operations, and most often the operations are functions. Here we'll just kind of be thinking about arithmetic, but functions too. Two operations are inverse to one another if one of the operations undoes any of the changes made by the other. So it's like if you have operation A happens, and then operation B does the exact opposite thing of operation A, and you end up back where you started, then those two operations are inverse to one another. And so we'll look at some examples, and these roots really are examples. And so we'll start with square roots, which you're all familiar with. One thing I've noticed students sometimes get a little confused between the square and the square root. And we'll see these two things are really opposite to one another. So you definitely don't want to confuse which one's the square, raising to the second power, and which one's the square root. And we'll do other roots in this video too, but you want to kind of keep that distinction clear. So taking the square root is the inverse of raising a number to the second power, or squaring, right? That's why it's called square root, because if you raise a number to the second power, you're squaring it. The opposite of that is called square rooting. So for example, the square root of 9 is 3, because you're looking for the number such that when you multiply it by itself, or you raise it to the second power, you get a 9 back. And I'm using an exponent here because we're going to tie all this to exponents. So instead of just saying multiplying by itself, I'm saying 3 squared, right? So this, it means the same thing, but so the square root of 9 is 3 because 3 squared equals 9, right? Another example, here's it laid out a little more pictorially. And thinking about inverses now, if I start with 5 and I square it, or in other words, I raise it to the second power, that gets me 25. And if you were to ask me what's the square root of 25, well, I need to undo the squaring. I need to figure out what's the number that when I square it, I get 25. So going the other way gets me to 5 because 5 squared is 25. So you get this nice little loop. And this sort of illustrates the idea of inverses, right? If I start over with 25 and I take the square root, I get 5, and then I square it again, I get back to 25, right? So you see this nice little loop. It's like if you do one thing, then you do the other, you end up back where you started. That's why it makes sort of a little circle here, right? Okay, so squares and square roots, I assume everyone's pretty familiar with. Cube roots you might have heard of, or you might have learned and forgot. Whatever, it's okay. Let's look at what these mean. You'll see it fits pretty nicely into a simple arithmetic system. So taking the cube root is the inverse of raising to the third power. So if taking the square root is the inverse of raising to the second, then the cube root is the inverse of raising to the third, right? So the cube root of 8 is equal to 2. Why? Because 2 taken to the third power is equal to 8, right? So again, the same thing with squares and square roots, cubes and cube roots. Same relationship, you've just changed what power you're taking. So here it's raised to the power of 3, or multiply it by itself 3 times. Again, I can look at it pictorially, like in this little circle that shows me how their inverse is. The cube root of 64 is equal to 4. Why is that? Because when I cube 4, or when I raise it to the third power, I get back to 64. Okay, so I got this nice little inverse operation going here. Fourth roots, if you've never heard of a fourth root, how do you expect it would work? Well, if a second root undoes raising to the second power, a third root undoes raising to the third power, well then a fourth root better undo raising to the fourth power. And indeed, to do an example, the fourth root of 81 is 3, because when you multiply 3 by itself 4 times, you get back to 81. Okay? So taking the fourth root is the inverse of raising to the fourth power, right? And I just want to say more generally, obviously there's no, it's just basic arithmetic. You can say, well, why stop at 4? There might be an example where I need to do a fifth root or a sixth root or a seventh root, kind of whatever. So you can take what they call the nth root typically for any number n. N might be 2, and then you're talking about square roots. N might be 3, and you're talking about cube roots. Whatever the number is, you can take that root, okay? And of course, what it means to take an nth root is to do the opposite, or invert raising to the nth power. So raising to the nth power, you're going to multiply a number by itself that many times, right? And you say, well, how do I undo that to get the nth root? What's the number which multiplied by itself n times gives me the thing I started with? And that's what nth roots are all about. And here's where I'm going to kind of leave you a little bit of a cliffhanger. So raising to the nth power, if you raise to a power, you're computing it using an exponent, right? So it would seem to make sense, or you might at least feel intuitively, well, if raising to the power and rooting, taking the root, the nth root, are inverse to one another, then is it also the case that you can write down roots using exponents? Okay, and of course, I'm strongly suggesting that you can, right? So here's what I mean, right? If I have a number x and I square it, okay, taking the square root is going to undo the square, and I'm asking, what number should I raise this? What should the exponent be, which would correspond to undoing the square? What's the thing that's going to undo raising to the second power? What's the thing that's going to undo raising to the third power? And my claim is that you can capture all these things, the square root, the cube root, the fourth root, or more generally the nth root, if you raise to the nth power for any whole number, any positive whole number, then you can put a number up in these exponents that will sort of make sense there. And how are you going to go about figuring this out? I want to remind you, I posted a video on sort of the basic ideas behind the algebra of exponents, or exponent rules. So you can use this exponent rule, for example, or the next one I'm going to show. You can use either of them to work out what the answer should be. So the first one, let's just quickly recall it. If I have x squared times x cubed, then I can add the exponents. If you multiply two powers with the same bases, then you can just add their exponents. 2 plus 3 is 5, right? And so why is that the case? Well, x squared, that means multiply x by itself twice. X cubed means multiply by itself 3 times. And so in total you have 5. And then more generally, even if these numbers aren't whole numbers, the rules sort of still make sense. So x to the a, that means you have a of these x's. X to the b, that means you have b. So in total you have a plus b, right? So that's one rule you could use to get to the exponents for nth roots. A second rule you could use is here. You could use either of these really. X squared raised to the third power. Well, you can multiply the two exponents, because if you cube x squared, you get x squared, x squared, x squared, which gives you 6 in total. And so the more general rule is x to the a raised to the b is equal to the product x to the a times b. So you should be thinking now in your head kind of how I can use these rules to figure out what should go here to do the inverse of the square. What should the power be? So I'm going to leave it at that. Thanks for listening and have a good one.